4.3, again, we are still solving quadratic equations just like we've been doing. The first section was solving by graphing, right? So looking for graphing the quadratic function. So x squared plus x plus 1 equals 0, something like that, and then graph that function, find the x-intercepts. That's 4.1. 4.2 was solving using algebra methods, right? Some more math stuff in there, I think. And then now 4.3 is solving by completing the square. So completing the square is something we did in chapter 3. So that should be something that you understand how to do. So now I'm just going to show you a few little things about how and why that works here. So I'm going to start off by doing some examples that you should recall. So this should be stuff that you've worked on before in math classes leading up to this. Oops. Okay, so when I say recall, that means, say, this is something that's a review. So if we were to solve something like this, we want to write these examples down. Example 1 says 2x plus 1 equals 25. So if we're going to solve this, we're going to get x all by itself, right? And so we're going to move that 1 to the other side. We're going to subtract 1 from both sides. So that's going to be 2x equals 24. We're going to divide by 2. And we have x equals 12. Okay? That's easy. Isolating for x. So over here, it becomes a little bit trickier when we have a similar type of equation, but we have a squared. So what we want to do now is we want to take the square root of both sides to get rid of the squared first. So we're still trying to get x by itself, but we're getting rid of the squared. So we have 2x plus 1 equals, now when we take the square root of 25 in a math question, you have to show that this is plus or minus 5, the square root. So it's plus or minus. I'll say that once again. If you have to take the square root of a number in solving an equation, you have to consider both the positive and the negative answer. Okay? So now solving for x becomes just the same as we did before. This is 2x equals, you have to consider the positive and the negative version of this square root. And it looks like this. Dividing by 2 gives us x equals this, plus or minus 5 minus 1 over 2. We can simplify this, right? 5 minus 1 is 4 over 2. And the other option, so here there are two solutions, negative 5 minus 1 over 2. That's negative 6 over 2. So the solutions here are obviously x equals 2 and negative 3. All right? So this is going to be important for today's lesson, being able to do this on the right side. Okay? So I want to show you this. This is the exact same question that we just did, but this question can be rewritten as this right here. Okay? So I just want to walk you through this. If we subtract 25 from both sides, I get what appears to be a quadratic equation equaling 0. So this is what we've been familiar with. And if we expand this out, okay, so this, if we expand it out, do our multiplication, I do 2x plus 1 times 2x plus 1, I get 4x squared plus 4x plus 1, which turns into 4x squared plus 4x minus 24 equals 0. Okay? So this is something that we've looked at last chapter as well. So again, what we can do is, we can't isolate for x here because x is in two different terms. It's squared in one and not in the other, so we can't combine those. We can't get x in one spot, all by itself on one side of the equation. So what we could do is we could take a greatest common factor out. And watch, this is different because it's an equation. Everybody watching? As an equation, I can divide both sides by any number. I do not have to show this as a factor on the left side. I can take, whoops, sorry, not 2. I could take 2, but I want to take 4. My bad. So I want to take 4 out. I can divide 4 out. That gives me x squared plus x minus 6 equals, what's 0 divided by 4? Still 0. You can divide 0 by any number, and it still remains 0. Any number other than 0 itself. So now, okay, so now we have some options here. what we've normally done is we've factored using the zero product principle, right? So x plus something, it's going to be x. This one's going to be a minus something. What are the two numbers that multiply to -6 and add to +1? That would be +3 and -2. So we can factor this trinomial this way. And this is what we did last section, right? So we have x equals -3 and x equals +2. So that's a bit of a review as well. You'll notice that those are the same numbers that we got up here. But, okay, solving it this way, you might like this way better than factoring. I like this better than factoring. If you don't have to factor a trinomial, usually it's maybe a bit easier. So here's some notes here on what we just did, and noticing some patterns here. So when you're solving an equation, okay, when solving, so here's some instructions. Divide both sides of the equation by the greatest common factor. Now that greatest common factor has to be a constant and not including a variable. So when you divide a greatest common factor out, it has to be a constant only. You cannot divide an x out of. Okay, that's no good. We need those x's in there because we need to find out what those solutions are. So you can divide a constant out. Then we can complete the square. Okay, or we can use the zero product principle, just like we did in this last example. The second method would be to isolate the squared quantity, and that comes with the completing the square part. So I'll show you the two different methods here. In example 2, we solved, so this is example 2 back here. So you could solve from this stage, or you could solve from the completed, by completing the square and factoring or whatever. So, okay, so just let me give you a couple examples here. So write these two examples down. They are the same equation, but I'm going to do them two different ways. Okay, zero product principle. Now, because it's an equation, I can divide out, completely out from both sides of the equation, any common factor. So I'm going to divide a 2 out from both sides. That's going to give me x squared minus 2x minus 1 equals 0. Okay. So now, can I find two numbers that multiply to -1 and give me -2 as a sum? Oh, not integers, right? Not integers. So we come across a little bit of a problem here. If we're trying to do the zero product principle, right, what are the factors of -1? Well, they're 1 and -1. Those will not add up to -2. Okay, so here's where we got a problem. You do the zero product principle, you're going to come up against a problem sometime. So let's just see what we can do, because we're kind of out of options really here. So let's try this. Let's try the second by isolating the squared part. So we'll complete the square. All right, so we can't do this. We're kind of stuck here. So let's complete the square. I could take a 2 out, so I'm going to do this. X squared minus 2x minus 1 equals 0, just like I did over the other side. But now I'm going to complete the square. And actually, what I'm going to do, and this is what they do in the textbook, this is one of the ways, I'm going to get this constant over to the other side. It equals 1. So I'm going to complete the square by doing x squared minus 2x plus something on this side of the equation. And then here's a slight difference. I'm going to add the same thing on the other side of the equation. So I'm going to get the constants on the other side. Slight difference from last chapter. But you'll see that this will work pretty well. So what's half of -2? That's -1 squared is +1, right? Or 1 here. So I add a 1 to this side and I add a 1 to the other side to make the equation balanced. So now what I've got is I've got x minus 1 squared equals 2. Okay, and then we can do is we can take the square root of both sides. square root. This is going to be plus or minus because I'm taking the square root of a number. So this is going to be x minus 1 equals plus or minus square root of 2. X is now going to be equal plus or minus square root of 2 plus 1. So this is why the zero product principle didn't work, because we do not have integer solutions here on this one. Okay? So the two x values are going to be root 2 plus 1 and negative root 2 plus 1. Those are my two solutions. So when you can't solve by factoring, or when the roots are not integers, then you're going to have to do something like this where you complete the square. And see, really what we're doing is we're getting, watch this, the x in two different terms. We're actually getting the x into one spot only. See this? I have the x in one spot only in this equation now. And that's the strength of this. That's what's going to help this. Okay? So these are the two answers. Okay? We're going to talk about a couple other things here before this lesson is done. Okay, so I need to talk to you about, and you guys should know this already, the difference between exact values and decimal approximations. So this right here, these answers right here, these answers right here are exact values. Okay? These are exact values. If you round this up, or if you do this on the calculator and you write the decimal answer, that's what a decimal approximation is. So let me just show you. So the square root of 2, the square root of 2 plus 1, this is the decimal for that. And if you write this decimal down, you have to round it. Even if you write all the decimals, all the numbers that are on your calculator, that's not all of them. This is an irrational answer. That means those numbers continue on forever. So if you write 2.41, okay, as an answer, that's an approximation. That's what this is. That's a decimal approximation. So in calculus, and this is pre-calculus, we are more interested in exact values than approximations. All right, and obviously there will be negative square root of 2 plus 1 as well. So negative 0.41. So x equals negative 0.41. So that's another decimal approximation, right? Which is what this is, the exact value. So there's a difference there, and we're going to be working with exact values, not so much decimal approximations. Okay, but there may be appropriate times in some word problems. All right, so we're almost done the lesson here. It's a shorter lesson today because completing the square is already something that we've looked at. So here's an example. This is the example that we did, this one right here. Okay, and this is one of the ways that they did it, by completing the square, which is what is new for this section. Okay. So this right here, completing the square, is one of the ways that you can get x in one spot only instead of in two spots where they're in unlike terms that can't be combined. That's the way you can basically get that x in one spot. All right? So solving by completing the square is what we're working on this section. And here is your assignment from 4.3. Okay, so you can write this down. That says 1 to 7, A and C for each. So 1AC, 2AC, 3AC, 4AC, and so on. Number 8, number 11, 13B, and 15 is optional. So if you get done this assignment, do 15. Okay? And especially for those of you that are looking for an extra challenge, then that's optional. All right? Hello? Okay, so for number 1, for those of you that are having trouble getting started, what value of C makes each expression a perfect square? So again, we're reaching back. This is review stuff. Like, So x squared plus x plus what? Basically completes that square. That's what they're asking. So you take half of b, that is 1/2, and you square it. So 1/4 is your answer. You're just finding this part. That's all this is. It maybe is packaged a bit different, but just take half of the b value, square it, and that's your c. Half of the b value, square it, and that's your c. Okay? If they give you decimals in the question, you can have decimals in your answer. If not, try and work with fractions, reduced fractions as much as possible so we can get comfortable with those. So that's A. C is 1/4. I'll do B as well here. So again, half of -5 would be 5/2, -5/2. So that's C is 25/4. Okay? Half of -5 squared.